Hi mathletes, welcome to this installation of more geometry, and in this video we're going to talk about tangents and circles, and really tangents to circles. Let's just jump in, okay, because this is exciting stuff. Are you ready? All right, first thing I'd like you to do, you have a circle in your notes, okay, and I want you to do this exploration. So I'm going to work the first one with you, but I'd like you to do the second two on your own and then come on back and we'll discuss it, okay? So first thing first, I want you to label the center of this circle P. Oh, you can do that. Okay, now I want you to choose 2 points on opposite sides of the circle. So maybe here, something like this. And label them A and C. Now I want you to draw a line from point A that only touches circle P in one point, at A, okay? So I'm gonna use a straight edge here, and it's kind of gonna look something like this. All right, and so, I'm going to do the same thing with C. I want to draw a line from C that only goes through the circle once, so something like this. All right, and I'm going to call the point of intersection of those two lines B. Okay, and so I would like to, okay, and so now you remember what line BC and line AB are called, right? These are called tangent lines because they touch the circle in exactly one point, okay, and it's exterior. All right, now I want to measure segment BC and segment AB, okay? I'm going to measure this with my handy dandy ruler and just see how those segments compare. Okay, it looks like segment BC is 7.5 inches, and it also looks like segment AB is 7.5 inches. Okay, so I'd like you to try that exercise with 2 other circles and see what your conclusion is. Okay, so how'd you do? Hopefully you kind of were seeing what I was seeing. When I did that here, I picked a couple of points on either side of my circle and drew the tangent lines. They both ended up being 13 inches to the point of intersection. I picked a couple of points on this circle, and they both ended up being 10.2 inches from the point of intersection here. And so really what this is alluding to is the idea that tangent lines from a common circle are going to form congruent segments to the point of intersection from the points of tangency. And that is the first thing that we need to actually make a note of in our notes. So let's do that now. Okay, so there are 2 main tangent theorems that have to do with circles here. And so this is the first one. So if you have 2 tangents drawn to a common circle and they intersect at a common point of intersection, then they're going to form congruent segments from that point of intersection to the points of tangency. So in our diagram here, if we want to kind of label what this is saying, we can say that line AB and line CB are tangent to circle P, and that segment AB is congruent to segment BC. And that's going to be true anytime you've got one circle, 2 tangent lines, they intersect somewhere. You can say that the segments that they form are going to be congruent. All right, now, how could you prove that? Based on what we've done so far in class, there is an easy way to prove this to be true. I want you to think about it. It will be one of the questions you'll see on the next test. All right, challenge accepted. Okay, the second tangent theorem. Here we go. A radius drawn to a point of tangency will be perpendicular to the tangent line. Okay, so this is kind of how this looks. And let's actually add the crucial bit of information. If I have a radius drawn to a tangent line, it's going to form a right angle because those lines will be perpendicular. Okay, so that's true if and only if the line is tangent, right? So you can tell a lot about a drawing then. It doesn't have to say the line is tangent. If you've got a radius drawn to a point here and it's a right angle, we would know it's a tangent line. Okay, so we can summarize that in symbols by saying segment AB is perpendicular to segment AP if and only if line AB is tangent to circle P. Got it? Okay, so now let's use these two theorems in some examples. Here we go.